So the greatest common factor is just finding what a certain binomial or trinomial has in common. What term do all of these three or four or however many things, what do they all have in common? What can they all be divided by? Well, in 2x squared plus 4x plus 10, the only thing they have in common is a 2. So when you factor 2 out, you'll get what's on the bottom. And that's how you find the GCF. The difference of squares is basically something squared minus something squared. So if you have x squared minus 4, this will be equal to x squared minus 2 squared to fit that definition. And you'll end up with x minus 2 and x plus 2, because those two things together equal negative 4. Perfect square trinomial is basically, in this equation, how 49 is a perfect square, and v2 is a perfect square. When the first and last terms of the trinomial are perfect squares, there's a really good chance it's going to be a perfect square trinomial. And basically all you do is find the square root of each of those. The square root of v squared is v. The square root of 49 is 7. So those two numbers will add together to make 14v, and they will also multiply to make 49. So that would be, your answer would be v plus 7 and v plus 7, but you can just rewrite it v plus 7 squared for it to be all the way correct. Factoring trinomials. All you have to do is find the GCF and then get what's left over, and it's really easy. So the GCF of this first thing, 2 squared plus 6x minus 36, the GCF of that is 2. It's the only thing they have in common. So you have 2, and then you write out the rest of it, and then you're trying to find out what two numbers equal the sum of 3, and what two numbers have the product of negative 18. And you'll get x plus 6, and then x minus 3, and you just need to bring down that 2. Factoring by grouping, all you really have to do is cut the problem directly in half, and you can see that big bold line I drew. Just cutting it in half. So down here we just have what this is, and all you have to do is factor out what's on this half. So the only thing that these have in common is x and y, so you factor that out, and then on this side you do the same thing, but you do it with negative 6. And you're going to end up with xy minus 6 and y minus 3. The sum of cube patterns is less difficult than it looks. This is an important formula, but if you just remember it the way I tell you, it's a little bit easier than trying to go back and put all the numbers in every single time. But basically you have these first two, 2x cubed plus 250. So, like we do on everything else, if you can, get the GCF. And this one can factor out 2. So you have 2 and z cubed and 125. Now what you have to do this time, instead of whatever you did with the squared patterns, you have to find the cube root. And this just means what times what times what equals z cubed, and what times what equals 125. So the cube root of z cubed is z, because z times z gives you z cubed. And the cube root of 125 is 5, because 5 times 5 times 5 equals 25. So, all you have to do is bring down the number you factored, which is that 2, and then you have the cube root of z cubed, which is z, plus the cube root of 125, which is 5. That's all you have to do to get that first one. And then all you do is basically you just square it, which I showed you down here very sloppily. So you have z squared, and then this one always has to be the opposite of this. So you're going to have a minus 5z, because you're multiplying 5 times z together, and then plus 25, because that's the what 5 times 5 equals 25. So that's how you do a sum of cube patterns. And then over here it's basically the same thing, you're just subtracting. So you're going to find the cube root of 64y cubed, which is 4y, and the cube root of negative 729z cubed, which is 9z. And all you're going to do is write that out and then square it to get your other trinomial. So 4y squared is 16y, and then these two multiplied together is the middle term, but it's going to have a positive sign because they have to be opposite. And then this is just the last one squared as well, which is 81 squared, 81z squared. And then the last thing to cover is really easy. And just a prime polynomial is something that cannot be factored. It can't go any further than that. And my example is x squared plus 5, because as you can see they have nothing in common at all. You can't do anything with them. So those are the different patterns of factoring.